Good afternoon. I'm Fatima Akhtar from Okayama University, Japan. I'm here to present my research entitled Improvement of Bit Distribution of Binary Sequence Generated by Alternative Tracemap Function, supervised by Professor Yasuyuki Nogami. My presentation is divided into 7 sections. I'm going to start with background and contribution. Pseudorandom binary sequences are generated by deterministic algorithm but exhibits randomness. For a pseudorandom sequence, it's difficult to predict next bit from part of the sequence. Using same parameters, same sequence will be generated. For these convenience, pseudorandom sequences are preferable to their counterpart, truly random sequence. So previously, we proposed such a pseudorandom binary sequence by an alternative tracemap function that has maximum period, high linear complexity, good correlation properties. But number of zeros and ones are not equal. So bit distribution is not equal and the sequence is not uniform. By principle, sequences must be uniform to exhibit randomness. To solve this problem, in this research, we have proposed a method of uniformization to make the sequence uniform and verified bit uniformity of the proposed sequence. Now I'm going to discuss about the necessary theories for this research. Primitive polynomial. A polynomial over Fpm where p is prime and m degree can be said primitive polynomial if it can generate p to the power m minus 1 vectors without any repetition, and the vectors can be generated by this formula. For example, if our p is 3 and m is 2, possible number of unrepeated vectors is 8, and if our considered polynomial is this, it can generate 8 unrepeated vectors. The 9th one is the repetition of the first one, so our considered polynomial is primitive. Primitive root. A primitive root is an element whose powers generate all non-zero elements of prime field. This table summarizes primitive root calculation for prime 7. 3 and 5 are primitive roots in F7, whereas other elements are not, since power of 3 and 5 can generate all elements in F7, all non-zero elements in F7, but other elements cannot. So 3 and 5 are primitive roots in F7. Now I'm going to discuss about our previous research. Suppose S is our proposed sequence of length lambda, then proposed sequence can be defined by this formula, where map is mapping function, and it can be written as in here. The output of map is a p-array sequence with elements 0 to p minus 1, which is converted to signed binary, and finally binary sequence is derived by this formula. Proposed uniformization method. So in our previous research, inequality begins from the output of mapping function. Mapping function outputs prime field elements, that is 0 to p minus 1. All non-zero elements are equal, whereas 0 are not equal and more. So in this research, zero elements are distributed equally among non-zero elements. To do this, we have utilized primitive root G. So, whenever a map 0 is encountered, it is replaced by G to the power K. As I said earlier, power of primitive root can generate all non-zero elements of prime field. So, this utilization of primitive root successfully distributes the zero elements among non-zero prime field elements. Now I am going to discuss about result. Proposed method is evaluated in terms of different length of bit patterns, and results are compared with our previous sequence. Result of bit distribution is considered on a sequence generated on P7M3 and this polynomial. So, when our pattern length is 1, proposed method generates sequence of equal number of zeros and ones, whereas in our previous research, there is a huge gap between number of zeros and ones. So, same pattern continues when higher length of bit pattern is considered. This is a significant achievement for proposed research in contrast to our previous method. We may conclude that we proposed a uniformization method for pseudorandom sequence and presented uniformization test result of the sequence. In future, we plan to examine NIST test to evaluate randomness, and we have plans to study theoretical proof for different properties. Thank you.